Hello friend, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about surface chemistry. This video is very beneficial for 12th students who is preparing for medical and engineering examinations. So friends, I welcome you in my YouTube channel. Let us start today our topic, surface chemistry. You know friends, this term adsorption, it is very confusing word with absorptions. Adsorption is different from absorptions. Only difference is B and D. So first command over this word and then go to the definitions. What is the definitions? The accumulations of molecular species at the surface rather than in the bulk of a solid or liquid is termed adsorptions. The molecular species or substance which concentrates or accumulates at the surface is termed adsorbate. Just keep in mind, adsorbate. And the materia on the surface of which the adsorption takes place, adsorptions takes place, is called adsorbent. Adsorbent. So now clear to you what is the adsorbate and adsorbent and the process adsorptions. Now friend, action of adsorptions. I will give you some point and just concentrate on this point. If a gas like oxygen, hydrogen, carbon dioxide, chlorine, ammonia, sulfur dioxide is taken in a closed vessel containing powdered charcoal, it is observed that the pressure of gas in the enclosed vessel decreases. What does it mean? The gas molecule concentrate at the surface of the charcoal. That is, gases are adsorbed at the surface. Now the second point is, in a solution of an organic dye, say methylene blue, when animal charcoal is added and the solution is well shaken, it is observed that the filtrate turns colorless. The molecules of the dye thus accumulate on the surface of charcoal, and that is adsorbed. Friend, the aqueous solutions of raw sugar, when passed over beads of animal charcoal, become colorless as the coloring substances are adsorbed by the charcoal. Friends, you know the air become dry in the presence of silica gel. Hence, because the water molecules get adsorbed on the surface of the gel, the process of removing an adsorbate substance from a surface on which is adsorbed is called desorption. So this point I think clear to you. Now what is the difference between adsorption and absorption? If this point will clear, then the most of the concept of this chapter will clear to you. So difference between adsorptions and absorptions. In adsorptions, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the adsorbent, while in absorption the substance is uniformly distributed throughout the bulk of the solid. A distinction can be made between the absorptions and adsorption by taking an example of water vapor. Water vapors are absorbed by anhydrous calcium chloride but adsorbed by silica. Just keep this example in your mind. Water vapors are adsorbed by anhydrous calcium chloride but adsorbed by silica. In other words, in adsorption, the concentration of the adsorbate increases only at the surface of the adsorbent, while in absorptions, the concentration is uniform throughout the bulk of the solid. Both adsorptions and absorptions can take place simultaneously also. The term sorption is used to describe both the process. Now, mechanism of adsorption. Inside the adsorbent, all the forces acting between the particles are mutually balanced, but on the surface the particles are not surrounded by atoms or molecules of their kind on all sides, and hence they possess unbalanced or residual attractive forces. These forces of the adsorbent are responsible for attracting the adsorbate particles on its surface. Friends, you know the extent of adsorptions increases with the increase of surface area per unit mass of the adsorbent at a given temperature and pressure. So, in this slide there is some important point. You just remember these points for the MCQ questions. The factor featuring adsorption is the heat of adsorption. During adsorption, there is always a decrease in residual forces of the surface. That is, there is a decrease in surface energy which appears as heat. Now friend, adsorptions therefore is invariably an exothermic process. Just remember it, invariably an exothermic process. In other words, del H of adsorption is always negative. When a gas is adsorbed, the freedom of movement of its molecules become restricted, and this amount to decrease in the entropy of the gas after adsorption, and that is del S is negative. Adsorption is thus accompanied by decrease in enthalpy as well as decrease in entropy of the system. For a process to be spontaneous, the thermodynamics requirement is that at constant temperature and pressure, del G must be negative and there is a decrease in Gibbs energy. Friends, on the basis of equation del G is equal to del H minus T del S, del G can be negative if del H has sufficiently high negative value as minus T del S is positive. Thus, in an adsorption process which is spontaneous, and combination of these two factors makes del G negative. So friend, you should also know as the adsorption process, del H become less and less negative. Ultimately, del H becomes equal to T del S and del G becomes 0. At this state, equilibrium is attained. Now, I will talk about types of adsorptions. There are mainly two types of adsorptions of gases on solid. Just remember it. If accumulation of gas on the surface of solid occurs on account of weak van der Waals forces, the adsorption is termed as physical adsorptions or physisorptions. When the gas molecule or atoms are held to the solid surface by chemical bonds, the adsorption is termed chemical adsorptions or chemisorptions. The chemical bonds may be covalent or ionic in nature. Chemisorptions involve a high energy of activations and is therefore often referred to as activated adsorptions. So this one is also an important point for you can note it. Sometimes these two processes occur simultaneously, and it is not easy to ascertain the type of adsorptions. A physical adsorptions at low temperature may pass into chemisorptions as the temperature is increased. For example, dihydrogen is first adsorbed on nickel by van der Waals forces. When molecules of hydrogen then dissociate to form hydrogen atom, which are held on the surface by chemisorptions. What is the characteristic of chemisorptions? This is the last topic of this video. Then I will further discuss about the surface chemistry in next video. So first you can see lack of specificity. A given surface of an adsorbent does not show any preference for a particular gas or as the van der Waals forces are universal. The second important point is nature of adsorbate. The amount of gas adsorbed by a solid depends on the nature of gas. In general, easily liquefiable gases with a higher critical temperature are readily adsorbed as van der Waals forces are stronger near the critical temperature. Now third point is reversible nature. Physical adsorption of gas by solid is generally reversible. Thus more of gas is adsorbed when pressure is increased as the volume of the gas decreases, and the gas can be removed by decreasing pressure. Since the adsorption process is exothermic, the physical adsorption occurs readily at low temperature and decrease with increasing temperature. We call it Leclerc principle. Now friends, surface area of adsorbent, and this is the most important point. So extent of adsorption increases with increase of surface area of the adsorbent. Thus finally divided metals and porous substance having large surface area are good adsorbents. Now friends, last point of this video is enthalpy of adsorption. No doubt physical adsorption is an exothermic process, but its enthalpy of adsorption is quite low, and this is because the attractions between gas molecules and solid surface is only due to weak van der Waals forces. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.